Hi guys. Okay, so today we're going to talk about this question, the expansion of this. Okay, where k and n they are both positive integers. Okay, the coefficient of x4 is equal to the constant term. Right? So write an equation connecting n and k. Okay, so we first start by expanding. Right? Let's expand 3 plus kx squared to the power of n. Right? Okay, so we are using the general binomial expansion. Okay, so with n0, 3 to the power of n, kx squared to the power of 0, okay, is n1, 3n minus 1, okay, kx squared, 1. And then n2, 3n minus 2, kx squared, power 2. Okay, so I'm going to stop here, although there are actually more terms behind, because I already got x to the power of 4, which is what the question wants, right? Okay, so now let's look at okay, simplify this expression first. Okay, so n0 is basically 1, and kx squared to the power of 0 is 1, so this is actually just 3 to the power of n, right? And n1 is basically n. Okay, and we have a 3n minus 1. Okay, kx squared. Okay, then we have a plus n2. Okay, n2 is n minus 1 over 2, right? Times 3 to the power of n minus 2 times k square x to the power of 4, right? Okay, so actually this term is not so important, right? Because what I really need is the constant term and the term that has x to the power of 4. Okay, okay, so okay, let's do a comparison. Okay, so the question says that, right, the constant term, which is 3 to the power of n, is equals to the coefficient of x to the power of 4. Okay, so this whole thing here is the coefficient, right, of x to the power of 4. Okay, so let's compare. This is n minus 1 over 2. And this is 3n minus 2, k squared, right? Okay, so let's try to simplify this a little bit. 3 to the power of n equals to n minus 1 over 2. This is 3n over 3 square k square, right? Okay, so basically, I can say that 1 is equals to n minus 1 over 2 times k square over 3 square, right? Okay, so let's simplify this a little bit more. We will get 18 equals to n minus 1 times k square. Okay, so yeah, we are actually done. Okay, so this is the equation connecting n and k. Okay, so for those of you who are wondering, how do I get from n2 to n minus 1 over 2? Okay, so this is how it works. Okay, so I'm going to use a different color to show you. Okay, so for instance, if I have nr, okay, this is basically n factorial over r factorial, n minus r factorial, right? Okay, so now if I have n2, this is basically n factorial over 2 factorial n minus 2 factorial, right? Okay, so let's simplify this a little bit. N factorial is the same as n times n minus 1 times n minus 2 factorial, right? Okay. 2 factorial is just 2 times 1, which is 2, and 2 and minus 2 factorial here. Okay, so You can see, right? We can actually do some cancellation. Okay, so this is the cancellation. Okay, so that is how we arrive at n minus 1 over 2, right?